Om Sri Sai Ram. Hearty welcome to Sri Satya Sai Lok Seva Gurukulam, secondary course NIOS syllabus. The topic is light energy. So I think all of you are full of energy now. You are hearing a lesson on energy. So light energy is a form of energy by which we can see the objects all around us. We can enjoy the beautiful nature by the light energy. Let us just try to recall the previous knowledge. So we know that light is a form of energy. What is the velocity of light? 3 lakh km per second or 3 into 10 to the power of 8 meter per second. So light travels. Can you just tell me which travels faster than light? Yes, it is our mind. It is here now. In a second it can go to any part of the world. Maybe Tokyo Olympics, or it may go to moon, stars, anywhere. So anyway, as far as human experimentation is concerned, the velocity of light is the maximum. And you know the applications of light. We can see this beautiful nature by light. The plants prepare food by the help of sunlight. And the solar energy is made use of for converting it into electrical usages like heating water, lighting system and so on. So there are very good number of uses of light. And one of the properties of light has many properties. One of them is reflection. How it is done? Reflection is done by using mirrors. What is mirrors? Mirrors are the objects which reflects the light. One of its surface is polished and it is an opaque substance, and this reflection of light is very, very important. We already discussed about that reflection in the previous class. And also you have seen there are 3 kinds of mirrors. One is called plane mirror. Second, spherical mirrors. In the spherical mirror you have 2 types. One is convex mirror and concave mirror. They come under what is called as spherical mirrors. We have discussed about the formation of image in a plane mirror. And we have seen some properties of plane mirror also, that it reflects the light. And it has got what is called as lateral inversion. Suppose you raise the right hand, you can see in a mirror as left. If you raise the left hand, in the mirror it looks as right. Is it not? And the property is called as lateral inversion. One more property is that the distance that you stand in front of the mirror, the same distance you can see the image behind it. And the image is virtual. What is virtual image? Virtual image means you cannot catch on the screen. So these are some of the things with connection to image formation in a plane mirror. And I need not tell about the uses of plane mirror. Every day you are using for combing your hair, is it not? And for gents it is used as for shaving purpose, and in many other decorations they use it, is it not? So there are a very good number of uses for plane mirror. Also, we have seen about the image formation in concave and convex mirror. Concave will give both real and virtual image. In all the cases it is real image, in one case it is virtual image. Whereas convex mirror always gives virtual image. And also we discussed about the uses of concave mirror, is it not? That is used in the vehicles, for lights, in searchlights, in dentists and all that. Convex mirror is used as a rear view mirror, that is used by drivers. You might have seen the right side of the driver, they use a mirror that is convex in nature, and that is called as rear view mirror. So these are some of the things which I have already studied in the previous class. Now coming to home assignments, we are given some homework. I think all of you have tried it. So in what condition the image formed by concave mirror is virtual? In all the 5 cases, the image is real. But in only one case, it is virtual. What is that one case? When the object is between focal point, that is F, and pole P. So between F and P, you can just imagine F and P. Between F and P, if you keep the object, the image will be virtual and it will be larger in size. It is erect. It is formed behind the mirror. Is it not? So that is the answer for the first question. Coming to second question, find the position of the object placed. This is a problem. In front of a concave mirror of focal length 20 centimeters, if image is formed at the distance of 30 centimeters from the mirror. So image F of image is formed after F, between F and 2F. So where should be the object placed? Answer is, it should be, object should be placed at distance of 60 centimeters. That means after 2F. So beyond 2F, if you keep the object, the image will be between F and 2F. Because F means 20, 2F means 40, between 20 and 40, 30 comes. And it will be real image and it will be inverted. It will be between F and 2F. So this is the answer. Object is to be kept beyond 2F. That is beyond 40. So that is the answer for the second question, and it is an understanding question. Now coming to the third question, write the nature of image formed in a convex mirror. In a convex mirror, the image is virtual. It is smaller in size. Virtual means what? If the object is like this, image also like that only, but it is smaller in size. Think of that it is a candle burning. and same candle can be seen inside the mirror in case of convex mirror. That is how in vehicles also you will see the small images of the vehicles coming from behind. That is called as rear view mirror. Why it is used, they are asking. In convex mirror is used in a side by the side of the driver. Why? To get a small virtual image. Suppose you are driving a car or a van or a bus, you should know which vehicles are coming from behind. Sometimes they overtake us. Sometimes they come in parallel to us. Sometimes they come very fast. All that to be judged. That will be done by rear view mirror. And it will be on the right side of the driver. So to get a small image, why should you get a small image? Because if they show the big bus that is coming, a lorry coming behind, it will be confused and driver will be in problem. That's why you must get a small image. And that's why you should keep a convex mirror by the side of the driver. So these are the answers for the home assignment. Now let us see today's topic. Now we will think of some formula. If two plane mirrors are placed at an placed inclined to each other at an angle theta, so what happens? The number of images of a point object is formed will be 360 by theta minus 1. What is the theta? Theta is an angle. This is how you call it. Sometimes they call it as alpha, sometimes they call it as beta, sometimes they call it as gamma, then theta, then eta, like that. In algebra we use x, y, z. Similarly, these are a Greek constant used to measure the angles. So, number of images is equal to 360 by theta minus 1. When 360 by theta is even integer. How do you get even integer? For example, if theta is 30 degrees, what happens here? So 360 by theta is the thing, becomes 360 degrees by 30. It becomes 12. So like that, if this 360 by theta becomes even, what are even numbers? 2, 4, 6, 8, 10, 12, etc. Here it is 12. Then number of images formed will be equal to 360 by theta, that is 30, minus 1. This is 12 minus 1, that is 11. So we get how many images? 11 images. Can you do an experiment yourself? Okay, try. Take two plane mirrors. Suppose you keep it in parallel. What do you get? Keep a candle in between. See, beautiful series of candles on both sides. Suppose you keep your finger, thousands of fingers you see when they are kept parallel. Now we are telling that if you keep at an angle of 30 degrees, so two plane mirrors kept at an angle of 30 degrees, acute angle. If you keep a candle in between, what happens? You get 11 images. That is in the case of even. Suppose instead of even, if you have odd, number of images of a point object formed is equal to 360 by theta if 360 by theta is odd. For example, if theta is 40 degrees, then you get 360 by 40 will be equal to 9. That is odd number. What are odd numbers? 1, 3, 5, 7, 9, etc. So this is odd. So there will be 9 images. Followed. Like that you can find out the number of images formed. Suppose it is 180 degrees. What happens? 360 by 180 becomes 2. You get only one image. If you keep both the mirrors like this side by side without an angle, if you keep the candle here with two mirrors side by side, you get only one candle you can see inside that. So keep it 90 degrees, you have 360 by 90, that is 4 minus 1, 3 images. So if you keep the candle here, you try this. Okay, it will be a very interesting experiment, and if you do so small experiment, you will be interested to do more and more experiments. Okay, so this is one formula. Now coming to sign conventions. To draw the image formation, you should use a sign convention. So this is a concave mirror. This is a shining surface. The surface which is coated with the metallic oxide. And this is what is called as principal axis. And this is the object kept at a distance. So now here sign convention says this is the direction of incident light. So direction of incident light from here to here. So this is the object. Okay. So if the distance are measured in the direction of the incident light, that will be positive in this side. If it is against or opposite to the direction of incident light, it will be negative. For example, here the distance is positive because it is in direction of incident light. Are you following? In the direction of incident light is always positive. In the direction against the incident light, it will be negative. Okay. And one more thing is, if the height is upwards, then it will be positive. Means if you are measuring the height of this, it will be positive. And if it is downwards, it will be negative. Are you following? So that means usually images will be downwards, real images. Then this will be the height. Should be taken as minus. This should be taken as positive. Okay. This is the sign convention used. Okay. So to measure distances with respect to curved mirror, following convention is followed. All distances are measured from the pole of the mirror. Okay, pole should be measured from the pole. The distance measured in the direction of incident light are taken positive. Just now I told about that. The distance measured in the opposite direction of incident light are taken as negative. Okay. The distance above the principal axis are positive, below the principal axis are negative. Just now what I showed in the figure. Okay. Using this, we have to get what is called as mirror formula. Formula is 1 by f is equal to 1 by v plus 1 by u, where u is the object distance, f is the focal length, v is the image distance. So the image formation, so this is the formula. How do you get it? For example, if you take an object kept at the center of curvature, means 2f, image also is formed there at 2f only. Then we have, so here 1 by minus 2f plus 1 by minus 2f. If you take LCM, it becomes, here this is u, this will be v, this will be u, because they are formed in the same place. Object also the same place, image also same place. You have seen the previous class, right? So you have the formula 1 by f is equal to 1 by v plus 1 by u. Very, very important. What is u? Object distance. What is v? Image distance. What is f? Focal length. Other day we discussed about definitions of all these things. Na? So this is using sign convention. It is not convection, it is convention. Okay. And you may ask, what is the necessity of this? This is to work out some problems on this. Now let us see some problems. Before that, we will see one more thing, that is called magnification. Say when you are small children, your length was so less. Say about 2.5 feet. Is it not? You ask your mother, she will tell. You are just about 2 to 2.5 feet in height. But now you are grown up 4, 4.5, 5, up to 5 something. Is it not? So now what is that magnification means? The increase in the, or you can say ratio, magnified effect. So ratio of the size of the image to the size of the object is called as magnification. We define it as m. M means size of the image by size of the object. Also it can be equal to image distance by object distance. Okay. So that is a magnification, means enlarging. You may also use it in mobiles. Suppose letters are very small or figures are very small. What do? You enlarge it. If you give one more tap, it enlarges, becomes bigger. So what is that bigger means what? It is magnification, increasing the size. That's all, simple language. Increasing the size of the object. So that is the ratio is called as magnification. This is the formula for that. M is equal to V by U. So now let us try to solve some problems on this. A concave mirror produces 3 times magnified real image of an object placed at 10 cm in front of it. So a concave mirror. So concave. This is called concave. This is called convex, which is hollow in the middle is called as concave. Bulged at the middle is called as convex. Simple. So now we are asking, where is the image located? And here they are given that this mirror gives 3 times a magnified object. So the image is 3 times bigger than the object. So where should we keep the object is placed at 10 cm from in front of it. Where will be the image located? Is it not? For that, magnification is 3, means it is 3 in size. Suppose the object is say 1 cm height the image is 3 centimeters. That's the meaning. Object distance is equal to minus 10. Why it is minus 10? It is against the incident ray. Therefore minus 10. Image distance is equal to what? That is the question. So m is equal to v by minus u. So if you cross multiply 3 into minus 10, it becomes v. So v is equal to minus 30 centimeters. Because it is a concave mirror, it produces always real image except in one case. And that's why you must write it as minus. Minus 30 centimeter is the image distance. Okay? Because magnification is 3. So if you put the ratio, 30 by 10 becomes 3. Is it not? So that is the answer for the first question. Now let us pass on to the second question. So this is the answer. All of you must write the answer in the end. Okay. Second question is, find the position of the image formed on a convex mirror of focal length 12 centimeters when the object is at the distance of 8 centimeters from the mirror. So here they are asking the position of image. So distance of the object is given, focal length is given, they are asking the image distance. So you have to use the mirror formula. So u is minus 8. Why it is minus 8? It is in the opposite direction of the incident ray. Focal length is 12. Okay. Now they are asking v they are asking. So use the length formula. 1 by v plus 1 by u is equal to 1 by f. This is called mirror formula. What is u? Object distance. What is v? Image distance. Like that you must repeat 8 to 10 times. Then only you can be clear about it. What is f? Focal length. Now 1 by v minus 1 by 8 is equal to 1 by 12. Now shift that 1 by 8 that side. If you shift it that side, it becomes positive. 1 by 12 plus 1 by 8. LCM is 24. 12 2s are 8 3s are. 2 plus 3 is 5. 5 by 24. That is 1 by v. So image distance v is equal to reciprocal of this. Is how you add it. No, fractions are added by taking LCM, right? So LCM of 12 and 8 is 24. How much time 12 is raised to 24? 2 times. 2 into 1 is 2. 8 is raised 3 times. 3 into 1 is 3. So 2 plus 3, 5. 5 by 24. And image distance becomes 24 by 5. That is 4.8 centimeters. Right? So that is one more numerical problem. Now we will see what is called as refraction of light. It's a very interesting phenomenon. So it's one of the properties of light. What do you mean refraction of light? When light goes from one medium to another medium, its speed changes and the light ray bends. This phenomenon is called refraction of light. The bending of the ray of light. How many have seen rainbows? Yes, all of you have seen, right? Free of cost. Need not give any money for that. When do you see rainbow? In the mornings or evenings? Now you will have some questions on this. You have to answer it, okay? I will answer the question tomorrow in next class. You think about that. Most of you may know it, okay? First question is, why the rainbows are formed either in the morning or in the evening only, not in the afternoon. Second question is, why it is formed in the eastern direction or western direction, but not in north or south? Third question, rainbow is always curved or semicircle in nature. It is not straight. Why it is not straight? Fourth question, rainbows are seen in the rainy season only, not in winter or in summer. Fifth question is, what are the different colors formed in the rainbow? Okay, so rainbow is a very, very interesting and very important application of refraction of light. Okay, now let us see some details about refraction of light. And see, I think you can also try very nice experiment. A coin placed at the bottom of a tumbler filled with water appears raised from the bottom. So this is Mr. X, maybe you only seeing. Actually coin is here at the bottom. Because it is filled with water, it looks little raised. Even swimming pools, you might have seen the bottom of the swimming pools look to be raised because of the refraction again. There are so many examples, so nice. Formation of rainbow during rainy season is a natural refraction, which I was just now telling you. It is also due to refraction only. So this is a very natural phenomenon, formation of rainbow. And try to answer the question which I posed today. Come prepared in the next class, okay? One more simple thing you can try yourself. If you take a glass filled with water, you must take glass and dip your one of the fingers, say forefinger, in water. See, this finger looks bulged. Even though you see your own finger, how it is? This interesting thing is that it is undergoing refraction. It is water media here, this is the air media here. So when a ray of light enters from a lighter medium to a denser medium, refraction take place. Okay, there is one more example. And one more simple thing you can also try. A pencil partially dipped in water kept in a glass tumbler. This is a glass tumbler with water. Only you must keep water, otherwise it won't give refraction. Of course, you may ask, what about other liquids? That also gives. But without any liquids, it won't give this interesting thing. Here, what happens? The pencil partially dipped in water. Half of the pencil is dipped in water. Appears to be displaced at the surface of air and water. Here we feel like that it is bent, but it is not bent, looks like that. Are following? So your straight pencil looks bent because of the property of refraction. Like that you can make a big list. So many things are possible, are very interesting in the refraction of light. Now we will see the definition of this refraction of light. So when you say refraction, you must think of medium. And what do you mean medium? The area around us. For example, air is there in between, right? Air is a medium. Water is a medium. Glass is a medium. When you say medium, there are two types. One is rarer medium Another is denser medium. What will be rarer medium? Rarer medium is one in which the particles are at large distances. Denser medium is one in which particles are compact, close to each other. So here when light passes from denser to rarer, it bends away from the normal. What do you mean normal? So this is a line, normal. Normal means a perpendicular line drawn at the one of the edges of the given medium or glass. So this is the perpendicular drawn, right? And this you have what is called as rarer medium, that is air. Air is called as rarer medium, and this glass is called as denser medium. So when a ray of light enters from rarer to denser, rarer medium to denser, it bends towards the normal. So it bends towards the normal. See, it bends towards the normal. And when it from denser to rarer, denser means what? This is glass. Glass is denser. And it is going to air. When it goes to denser to rarer, it bends away from the normal, going away. Is it clear? The two cases you must know clearly. And see, here it is going away from the normal because denser to rarer. Rarer to denser towards the normal. What is normal? Normal is a straight line drawn perpendicular to the given medium. Okay, so that is a very important property of refraction of light, and this is called as angle of incidence. This is called incident ray, where the ray will be coming and entering the medium. This is called normal. This angle is called as angle of incidence. And when it comes inside the medium, namely glass, it goes like this. This is called angle of refraction. Means the ray of light gets bent here. So that is called angle of refraction. So on this only we have one experiment. It's a 4-mark question. Please learn it carefully, right? So it is a glass slab. This glass slab is to be kept on a drawing sheet. And with the help of drawing pins. So you should have a drawing board. On the drawing board, you have drawing sheet. So you have to fix up a drawing sheet. How do you do drawing sheet? You have to fix it with the nails. There will be specific nails for that, special type, that you have to fix it in the corners. And for that you want drawing pins. They are called as drawing pins. So, okay, first you have to fix the sheet. After fixing the sheet, you have to keep what is called as glass slab. This is called as glass slab. And glass slab is kept in the middle of the sheet. And its boundary is to be marked. Why you must mark the boundary? During experiment, there are chances it may be displaced. Therefore, you should make a boundary. Draw the two normals. One is called N1C, N2. Another one N3D, N4. There are 2 points called C and D. Point of contact. And this is called incident ray. Here A and B are called the pins. By seeing the pins in the other side of the slab, we have to fix up two pins E and F so that both of them come in the same line. This is actually the line. This is the actual line. But because of refraction from rarer to denser, the line got deviated. Like this it is deviated. Then from denser to rarer it goes away from the normal. It's like this. So actually this line should have been like this, but because of refraction it got deviated. This is an experiment which shows the laws of refraction. Okay. Now we will see what are the laws of refraction. Once again we will see the explanation here. A glass slab is kept, 1 point. Center of a drawing sheet, 2nd. Drawing board, 3rd. The boundary is to be marked, the slab is marked using pencil. So marking the boundary. Let line OC is marked the boundary line obliquely. Two pins A and B are fixed on that line. Two pins E and F are fixed on the other side of the slab so as to come in the line of A and B. The slab and the pins are removed. The points E and F are joined to meet the boundary at D. Okay, that's what you have seen just now. Same thing is explained here. See, A and B are two pins, E and F are the other two pins. They look to be in the same line. And these are the normal donuts C and D. Okay. Now using this, what you are observing? You are observing that there is a deviation in the line of the image. So the line ABC gives the direction of incident ray. DF gives emergent ray. And inside the glass slab, we have the refracted ray, CD. The normal NC1 and 2 at C, normal N3, D, N4 at D are drawn. So at C and D, we have to draw two normals. Okay, so you draw the figure also. Practice it correctly. And if you have a glass slab in your home, you can do this experiment also. It's a very, very interesting experiment. If you go to schools, you tell your teachers to do it. Okay. Ray of light when going from a rarer to a denser medium bends towards the normal. Ray of light going from denser to rarer bends away from the normal. This is already we have discussed about that. So you have a very interesting formula called refractive index of a medium. It is a ratio of speed of light in vacuum to the speed of light in the material. So speed of light in the vacuum by speed of light in the medium. This ratio is called refractive index, usually called by small n. So you can write it as V1 by V2, velocity. And why that velocity changes? Because it is easy for the particles to move in a rarer medium, because particles are at large distances. When they come to denser, it is difficult. Okay, that's why the speed reduces. So this ratio is called refractive index of the medium. And we'll work out some home assignments today. First one, a ray of light traveling in air enters obliquely into water. Does the light ray bend towards the normal or away from the normal. Why? The refractive index of diamond is 2.42. Each substance has got different refractive indexes. For diamond 2.42 means what? What is the meaning? A concave mirror produces 3 times, magnification is 3, magnified real image of an object placed at 10 cm in front of it. Where is the image located? Means you must tell the position. Okay. So these are the 3 home assignments. Come prepared. Okay. Thank you.